All right, now we're going to fit a probability model for the 5-day change. So highlight that and go to fit and fit. So here it's expanded the data all the way to D2. So we need to change that to D6. Okay, so 5-day change. Now distributions that we want to consider, okay, this is not, you could have negative values, so no lower bound, no upper bound, so we're going to leave it as unsure, and we will leave a key information as our criterion for selecting best fit. Okay, so let's leave the defaults as is and click OK. And now we have some possible fits, right? So let's say this is your best fit according to AIC. So let's paste that distribution here. So write to Excel. So that's our Laplace. Click next and we click that cell. So that gets inserted there. So now we go back to fit, go to fit manager, so go back to fit, and we already have defined fit to 5-day, so we'll select that, right, and click OK, and now we will select logistic, that's the second best, we'll put that here. Okay, so we have risk logistics and risk Laplace. Now let's do one more. So go to our defined fits. Okay, click OK. Now your textbook is given an example with the ext value. So we'll do the same. ext value min. So we'll use that. Okay, so that's what we're going to fit here for that one. So next, we're going to put it here. All right, so we have simulated returns based on 3 different distributions. Okay. Now the return is that. Okay. So now we're going to set these 3 as our output that we are interested in. Okay. Click output define. So here are the 3 outputs that we have defined. Click OK. Now we want the first percentile from here. So at risk percentile, okay, of that, right? No, so we have risk percentile, okay, of that, and we're going to only do 1%. Okay, so that would be the first percentile return using the best fit. Okay, copy that down. And then value after 5 days will be $1,000 times 1 plus that return. Okay, so now we need to make sure that G3 is absolute referenced. Okay, so let's get rid of that. And then value at risk will be that minus, okay, so absolute reference that. All right, so now let's put the borders back. Okay, now we are ready to simulate. So let's go to at risk. Let's check the settings. Okay, so multiple automatic. All right, so click OK. And then make that 10,000 and simulate. Okay, so now we have value at risk. Okay, and the simulation pattern, we have the best fit gives you an estimate of $82. Second best is $70, and then $131 for this distribution. So what this means is that what probability distribution we use is significant because the value at risk changes so much. So what if we fit the data, just one data? This is a sample of one, right? We took a sample from 2016 to 2019. And so not only that we have uncertainty about the parameters that we have, like here we have in Laplace, we have those parameter risk. Why are these parameters, what confidence do we have that these parameters are right? So that's one level of risk. And the second level of risk is the distribution itself. So we're going to now look at how to mitigate the parameter risk. Parameter risk meaning, what if these two parameters that we have estimated using the fit feature, okay, so how do we simulate that, the parameters themselves?